Alright, let's look at the homework 10, problem number 2. Let's do part A. Alright, first, so we have orthogonal matrix, and we want to see if it's a rotation or reflection. Alright, let's find the determinant first. So determinant of this matrix would be 0, negative 1, 0, 0, 0, negative 1, 1, 0, 0. Alright, so I'm gonna expand along, say, first column. Alright, so this is gonna be plus, and this is gonna be negative. This is gonna be positive. So it's at 0, 0. So I don't have to do anything. So it's gonna be positive 1 times submatrix would be determinant of negative 1, 0. 0, negative 1, right? So this is going to be negative 1 times negative 1 is 1 minus 0, which is going to be positive 1. So this is going to be a rotation. There is no reflection. Right? So we have a rotation. So in order to find the axis of rotation, we need to find the fixed point. So what we do is we're going to have try to find a fixed point. So multiply this matrix and apply this matrix to, say, x, y, z, and which is going to, I'm going to set that equal to x, y, z. But if you multiply together, you're going to get this times that gives you negative y. This times that gives you negative z. This times that gives us x. Since we want the fixed point, so we're going to set that equal to x, y, z. Alright. So it seems like, so we got this equation, right? We want x equals z, right? So that's easy, all right? Then it said, this one says that y is a negative z, so y equals negative z, and this one said that y equals negative x, which is the same thing, so y equals negative x, right? So only condition would be, so we can just pick one example. Alright, so we want, let's see, x and z to be the same. So I'm going to just use the 1 and 1 for x and y, x and z. And y has to be negative of z, so it's got to be negative 1. Alright, so axis of rotation. Alright, we can take it to be 1, so can take it to be 1 comma negative 1 comma 1. Right, so we have that. Then we want to find the angle of rotation, so let's do that. So I'm going to just keep on multiplying by itself and see what happens. Alright, so one rotation. So let's say if you do 2 rotations, where would it go? So I'm going to just multiply by itself. So 0, 0, negative 1, 1, 0, 0. Alright, you end up with, let's see, so this times that gives you 0, 0, 0. Alright, so you get 0. So this times that gives you 0. This times that gives you 1. Alright, this times that gives you negative 1. And this times that gives you 0. This times that gives you 0. Alright, this times that gives you 0. And this times that gives you negative 1. This times that gives you 0. Alright, then we multiply by another matrix. It's the same matrix, and see what happens. So if you do this times 0, negative 1, 0, actually, let's see. I'm gonna just let's see. I don't like. I'm gonna just copy this 0, 0, negative 1, 1, 0, 0. If you multiply by, so this was 2 rotations. 0, 0, 1, negative 1, 0, 0, 0, negative 1, 0. Right? What you're gonna get would be this times that gives you 1. This times that gives you 0. This times that gives you 0. This times that gives you 0. This times that gives you 1. This times that gives you 0. This times that gives you 0. This times that gives you 0. This times that gives you 1. Right? So that means that when you do 3 rotations, you're going to come back to the original place. So 3 rotation equals 360. So rotation angle theta would be either a positive or a negative 120 degrees. Right? So we want to see which one. So what we're going to do is we're going to actually do a little bit of observation. All right. So axis of rotation, we took that to be 1, negative 1, 1. So here is the axis. Right. So here's the x-axis, and this is the y-axis, and then here's the z-axis. So axis of rotation is pointing this way, so it's going to be positive 1 and a negative 1 on y. So I'm going to extend the y-axis this way, so it's going to be negative 1 here and a positive 1. So you can see that the axis of rotation points this way. All right. Then what we want to do is I'm going to just apply, say, apply this same matrix to the I vector. So, for example, if you do, say, 0, negative 1, 0, 0, 0, negative 1, 1, 0, 0, apply to 1, 0, 0. Then see, just observe which way it's going. All right. So this times that gives you 0. Right? This times that gives you 0. And this times that gives you 1. Right? So looks like this vector, I vector, is going to be sent to z vector. So this is going to actually rotate this way. Right? So since we are going in the counterclockwise direction, so this is going to be positive 120. So answer is positive 120 degrees. Right? Then axis of rotation is 1, negative 1, 1. So that tells you the direction. Right? Well, you can also write it in this way. You can write it as vector I minus vector j plus vector k. Right? So that's it. I hope that this was clear.